Alright guys, welcome to Module 5. This is Chapter 8 of the Parasitology book. So this will be the last lecture, last chapter that we cover in the Parasitology book, and then we're going to be moving to Coleman's Color Atlas of Diagnostic Microbiology. The next two modules are also going to be mostly just focused off of the lecture slides that you guys will get. So don't stress too much if you don't have the book. Well, actually, if you don't have the book, you're going to have to get a copy to do your outlines. But don't stress too much because not all of the pertinent information is going to be in the book. It's mostly going to be from the lectures. Um, when I was making this course, I didn't realize that this chapter was so short and not very involved. So this week is kind of a free week for you guys, but also at the same time, not really, because next module next week is going to be rather time consuming. So take the little bit of time it takes to finish this week's module and go ahead and get started on next week's module already, because it's going to be rather time consuming. So this week we're covering chapter 8. It's called Control and Treatment of Parasitic Disease, and we're just going to do a general overview here in this lecture. We're not going to get too far in depth because um, this stuff that isn't really as important for us as laboratorians as it is for somebody who might be in public health or epidemiologists and so on and so forth. So your learning objectives are listed here. Again, remember I told you guys that it would be these are here for you to go through the book and answer these objectives, or be able to answer these objectives, because they're going to help you with the quizzes. So just a general introduction for this chapter. Parasitic relationships. So from the parasite's point of view, the best relationship it could have with the host is one in which the host would suffer little or no harm, because this allows the parasite to survive. So in general, most parasitic infections, the host is not gonna have very little or no harm, because the parasite is actually living and taking away from the host. So obviously we want to get rid of them so that we can be healthy individuals. So treatment assumptions, most people are going to believe that somebody who's infected with parasite disease can control the disease, because they could either avoid somebody who's infected and believe that they're not going to catch an infection. People believe that good hygiene and taking medication lessens the infections or ability of uh, a parasite to cause disease. So there is a decrease in incidence around the world because people are generally taking steps to avoid parasitic infections. I know in Africa they're putting up nets to try to keep mosquitoes out and so on and so forth. But it's a lot more complicated than just simply taking these steps or treating a parasitic infection. Generally, a parasitic disease is just like a microbiological disease or any other disease for that matter. It's complicated, and it's all about how well, how susceptible a person is, and just nature, survival of the fittest type thing. So defining terms here, these terms are defined in your book, but I'm just going to go ahead and read these definitions for you since this is part of the lecture. So epidemiology is the study of relationships of the various factors that determine the frequency and distribution of an infectious process or disease in a community. The results of these studies are used to help control health problems. So most of you guys know that epidemiology also can be referred to as public health, or a public health person might be performing epidemiology, but basically we're studying disease and disease processes and learning how we could better control them. An epidemic is an infectious disease that attacks many people at the same time in the same geographic region. And so an example would be an outbreak of cryptosporidiosis. Um, some of you guys might have watched the show Contact, where there's a viral infection, and that's what an epidemic would be, where a disease is attacking a lot of people in the same general region. An endemic disease is one that occurs continuously or expected cycles within a given population, with a certain number of cases expected over a given period. So an example of an endemic disease would be malaria in Africa. Pathogenicity is the parasite's ability to produce pathological changes and disease in or on a host. To be pathogenic, a parasite must be able to colonize a host and grow and produce toxins that induce response by the host or directly cause tissue damage. The progression and extent of the infection is related to the number of organisms living within the host, the parasite's virulence, and the extent of the host's response. So basically, pathogenicity is the ability of an organism, or in this case, a parasite, to cause a disease process within a human or a host. But the only host we're worried about is humans. Virulence. So virulence, you guys might have remembered this from microbiology, or those of you who haven't taken microbiology yet, you're going to want to take note of this word. Virulence relates to the ability of pathogenic organisms to thrive in a host, including the abilities of the parasite to attach or adhere to target tissue or cell, release enzymes or toxins that damage or interfere with normal host functions, resist or evade host defense mechanisms, and produce and distribute offspring effectively. So that definition is a little bit involved, but virulence is basically the ability of an organism to cause a disease and the extent of that disease. So the more virulent an organism is, the more a host, or in this case us as humans, are going to feel or experience that infection. Essentially, it's like the strength of an infection. So when we think about controlling parasitic diseases, the book suggests that we ask some necessary questions. What is the cost and benefit of controlling this parasite? What would happen if nothing were done about the problem? What controllable factors affect the host's ability to respond to the disease? So let's go back and answer some of these questions a little bit. So treating a disease represents the final and most direct interruption of a parasite's life cycle. So basically, what are going to be the cost and benefit of controlling a parasite? So when you think about cost, how much is it going to cost to either treat parasitic infections or kill the parasite or stop a vector from introducing a parasite into a human host? What is it going to cost? And what are going to be the benefits of that cost? So a lot of times in the business world, you hear about cost benefit analysis, and essentially that's what we would have to do with a parasitic infection. The next question is, what would happen if nothing were done about the problem? So if we never did anything to try to control a parasitic disease, what could happen if we didn't do it? If we didn't stop malaria from infecting humans, how fast would that disease spread? How many people would die, things like that. So essentially, what's going to happen if we don't treat? Are people going to keep dying, or is this infection eventually going to go away on its own? Do we need to take action or not? What controllable factors affect the host's ability to respond to the disease? So, what are some things that we can do as hosts, or as humans, or as medical professionals to affect our ability to respond to the disease? So, can we take more vitamins? Can we take certain prophylactics, things like that? So, what are we as the host able to control? So, more necessary questions: what controllable environmental factors affect the life cycle? So, when we think about environmental factors, we want to think about the vectors. So, these flies, these mosquitoes, these ticks that are intermediate host, or infective hosts, or just vectors, for these parasites. How can we control those factors? Are we going to spray to get rid of these parasites? Are these mosquitoes or these flies? Can we put up nets like they do and mosquito nets to try to prevent these mosquitoes from getting in and infecting us with parasites? If we have water that is known to have Giardia in it or other parasitic infection, how can we control how can we filter or control that environmental factor to get rid of those parasites so more people aren't being infected? And that kind of ties into the next question: can the life cycle be interrupted without host cooperation? So, the life cycle of a parasite, if the parasite can't move on to a definitive host where it's going to mature into the um, reproductive stage where they're going to produce more parasites, is that parasite or parasitic infection going to continue? So an example of this would be if we can get rid of the mosquitoes that are um, helping these organisms reproduce inside the mosquitoes so they can become the infective stage once they're introduced to a host, us as humans. If we disrupt the life cycle and get rid of the mosquitoes, what happens to that parasitic infection? Does it go away? Does that parasite stop causing disease? Will it find another host? What can we do? Can and should the host be protected from exposure to the parasite? How much can we protect ourselves from being. Sorry, I had to pause to cough and I forgot what I was saying, but how can we protect the host from being exposed to the parasite? And then is there effective vaccine available? So um, I'm not entirely sure what parasites you could probably possibly have a vaccine. I don't remember covering any in my lectures, but I think it's possible that there might be a vaccine for malaria, but is there an effective vaccine available? That is a good question because I don't know. So I guess that's that's a very good question. So controlling parasitic disease. So chemical vector controlling strategies. So to control the spread of other parasitic diseases, chemical measures have had varying degrees of success. So we could treat a local environment because there are some dormant stages, some eggs and cysts. They're usually resistant to toxic substances, but we could also use chemical means to uh, control the vectors, as I've been saying. We could spray and use dips to get rid of our flies and our mosquitoes and so on and so forth. With malaria, again, we have vector control, so that means that we're going to reduce the infected arthropod host populations, and then we're going to reduce the human exposure. So some of the ways that we reduce that mosquito population is that we're going to treat areas and spray basically to get rid of the mosquitoes. DDT isn't used anymore because it was reducing the ozone layer, so we have to look at other ways to spray and get rid of uh, these mosquitoes. Now, barrier strategy, again, this is simply just putting up a barrier, so something, nets to keep those mosquitoes out and away from humans so that we can't get infected. Biological and environmental strategy. So um, here it's going to be chemical controlling again to try to get rid of the vectors. I'm reading in the book, and there's in Central Africa, they're actually controlling the environment to make it so that some of these parasites cannot grow or live, or the vectors will not live in the areas that they generally do because they've changed the environmental aspect of it. So they're going to control gnat populations by um, taking the salt out of water, essentially, various things like that. So other control strategies. Again, I just mentioned that there might be a vaccine available, and I wasn't sure what parasites might have a vaccine, but then I started looking through the book, and the schistosoma species actually has a vaccine available to prevent infection with those diseases. So in Brazil and South America, they have vaccines to the schistosoma parasites. The book also states that some places are breeding certain fish that eat mosquito larvae, so then we're going to use these fish uh, to control the population of our vectors so that we can lessen our ability to get infected, essentially. So then the book also discusses human behavior and culture. So dietary customs have been changed in some areas. So in some cultures where it's common to eat undercooked beef, meat, or fish, people are actually changing their culture and behavior to prevent parasitic diseases. So, uh, they might be cooking their beef and cooking their fish to get rid of these parasites. And they're also going to be changing the way they live to try to reduce contamination with parasitic diseases. And again, this is something you guys will uncover when, as you guys are outlining these chapters. You guys are expected to be reading this book and highlighting the main points. So you could get the main points a little bit from lecture and a little bit from your own readings. So examples of parasitic disease: so protozoan infections, pinworm infections, schistosomiasis, jungleitis, iasis, and malaria. I'm not going to go through and discuss these parasitic diseases because you should have gone through them already throughout the previous chapters. So we're going to go right into treating parasitic diseases. So let's get into this a little bit. We're not going to get into treatment too much because that's not really our area of um, expertise as laboratorians. So, treatment of parasitic diseases relies heavily on accurate diagnosis and then follows by good judgment on part of the physician. So, drug effectiveness versus the toxicity of that drug are something that providers are going to have to consider. We're also going to have to consider the parasite's location, numbers of the parasite in the host, how long the treatment should occur, the method of the drug administration. If only one drug is available, is the patient's condition enough to bad enough for us to have to introduce a treatment plan or not? So these are just a lot of things that physicians have to consider when they're treating parasitic diseases. The CDC provides detailed information about treatment and use of various drugs, but it's generally up to the physician how they want to treat parasitic diseases. That's not really something we as laboratorians monitor, but it's something that we would have to consider in the off chance that we have to do laboratory monitoring of this treatment. So in certain cases, if the treatment's going to be extremely harmful to the human, we as laboratorians are going to have to keep an eye on the chemical, urinalysis, things like that to make sure that it's not affecting our organs too much in their treatment plan. And I've already kind of went through this summary again. Like I said, the the drug treatment is not really something that we're too worried about as laboratorians. But for those of you guys who are interested and to help you answer some of the quiz questions, you could look through table 8-1 on page 176, and that table goes all the way through to page 180. And this uh, chart really does a really good job of breaking down the parasite, the type of infection it causes, the type of treatment that it might be used, and then kind of adverse reactions. So one of the things here is Giardia. So the Giardia, it's going to be treated with metronidazole, but some of the reactions to that is going to be nausea, headache, vomiting, diarrhea, vertigo, insomnia, ataxia. So it's important for us to go ahead and take a general look at this. But if you look at this chart and you look at the adverse reactions for the treatments, there's a reaction for almost every single treatment for one of these parasitic diseases. So that's why it's important for the doctors, us as laboratorians, to provide accurate diagnoses. So we have to tell them an accurate parasitic organism. We can't just say, well, I think it's going to be a Strongyloides species or it's a schistosoma species. We have to give a very specific diagnosis so that we could give a very specific agent to kill that parasite so that we reduce these adverse reactions. But whenever you guys are going through and taking your quiz, I highly recommend that you use this chart to help you out. So it's page 176 to page 180. And happy studying.